The modern world relies on science, mathematics, engineering, and medicine for its survival. From buildings that graze the skies to the microscopic building blocks of life, there is one unifying element that connects every aspect of our world: chemistry. Chemistry is one of the most beautiful yet complex sciences out there, and the basis of chemistry is the periodic table. Every gas, every liquid, every solid ever discovered lives in this beautiful, harmonious arrangement that dictates the rules and regulations of the compounds that occur naturally or synthetically. Hundreds of years, thousands of experiments, and millions of hours of research have gotten us to where we are today, with the periodic table consisting of 118 elements. From the abundance of hydrogen to the extraordinary scarcity of oganesson and everything in between, these 118 elements make up everything we know and everything we ever will know. Today we rank these elements using an arbitrary system to see which elements stand above the rest and which ones deserve the utmost recognition for the things they do for us. Let's explore the world of chemistry and see what this magical table has in store. Starting with hydrogen. Hydrogen is the first element on the periodic table. Hydrogen is highly reactive with oxygen, forming water, and is also used as a fuel in rockets. Hydrogen is the lightest element and the most abundant in the universe, primarily found in stars. The essential element for anything and everything, hydrogen is an S-tier element. After hydrogen is helium. Helium is the second element on the periodic table. Helium is almost completely chemically inert and doesn't readily react with any other elements. Helium was discovered in the sun's spectrum before it was even found on Earth. It is also used in balloons because it is lighter than air and non-combustible. Truly special but sometimes overlooked, helium is an A-tier element. Next comes lithium. Lithium is the third element on the periodic table. Lithium is highly reactive and can readily react with water, releasing hydrogen gas. Lithium is the lightest metal on the table and is also used in rechargeable batteries. With so many practical uses, lithium is an A-tier element. Afterwards comes beryllium. Beryllium is the fourth element on the periodic table. Beryllium resists reacting with air or water, but its compounds can be toxic. Beryllium is extremely lightweight and strong and is used in aerospace applications. Interesting but not very entertaining, beryllium is a B-tier element. Next up is boron. Boron is the fifth element on the periodic table. Boron is chemically inert at room temperature but reacts with almost all metals at high temperatures. Boron compounds are used in many applications from cleaning agents to borosilicate glass. Quite useful but not very memorable, boron is a B-tier element. After boron is carbon. Carbon is the sixth element on the periodic table. Carbon has a wide range of reactivity depending on its form. Carbon forms the basis of organic molecules and exists in various forms such as diamond or graphite. The building block for almost anything and everything, carbon is an S-tier element. Following carbon is nitrogen. Nitrogen is the seventh element on the periodic table. Nitrogen is relatively inert as a diatomic molecule, but it forms reactive compounds like ammonia and nitric acid. Nitrogen gas makes up about 78% of the Earth's atmosphere and is crucial for life. Another cornerstone of human life and activity, nitrogen is an S-tier element. Next up is oxygen. Oxygen is the eighth element on the periodic table. Oxygen is essential for combustion and respiration, making it highly reactive with many elements and compounds. It is also a key component of ozone, which protects us from UV radiation. One of the most recognized and remarkable of them all, oxygen is an S-tier element. Next is fluorine. Fluorine is the ninth element on the periodic table. Fluorine is the most reactive element and readily reacts with almost all other elements due to its strong electronegativity. Fluorine is used to fluoridate drinking water to improve dental health. Very useful and very reactive, fluorine is an A-tier element. Next up is neon. Neon is the 10th element on the periodic table. Neon is chemically inert and is often used in neon lights due to its bright red-orange emission. Neon lights are created by passing an electric current through neon gas, causing it to emit colorful light. One of the most beautiful elements out there, neon is an A-tier element. Following neon is sodium. Sodium is the 11th element on the periodic table. Sodium reacts violently with water, producing hydrogen gas and sodium hydroxide. It is also a key electrolyte in our bodies and one of the main components of salt. A vital part of everyday life, sodium is an A-tier element. Next on the list is magnesium. Magnesium is the 12th element on the periodic table. Magnesium is quite reactive and burns brightly when ignited and often is used in fireworks and flares. Magnesium is also important for both plant life and animal health. Incredibly interesting and important, magnesium is an A-tier element. Next up is aluminum. Aluminum is the 13th element on the periodic table. Aluminum's reactivity is low due to its oxide layer, which protects it from further oxidation. Aluminum is also one of the most abundant metals in the Earth's crust, making up roughly 8% of it. Not bad, but not great either. Aluminum is a B-tier element. Next we have silicon. Silicon is the 14th element on the periodic table. Silicon forms strong covalent bonds and is used in electronics due to its semiconducting properties. Silicon is a key component of modern electronics and is used by engineers to build switches, circuits, and gates. Quite useful in many applications, silicon is an A-tier element. Up next is phosphorus. Phosphorus is the 15th element on the periodic table. Phosphorus can react with air to form phosphorus pentoxide, producing a characteristic white smoke. Phosphorus is crucial for life and is a component of DNA, RNA, and ATP. A part of life that we truly will not be able to live without, phosphorus is an S-tier element. Next on the list is sulfur. Sulfur is the 16th element on the periodic table. Sulfur can undergo combustion to form sulfur dioxide gas, responsible for the smell of burnt matches. It is used in various industries, including the production of sulfuric acid, a potentially life-threatening compound. Very exciting and oftentimes scary to work with, sulfur is an A-tier element. After sulfur is chlorine. Chlorine is the 17th element on the periodic table. Chlorine is a highly reactive halogen and can react explosively with hydrogen to form hydrogen chloride. Chlorine is often used for water disinfection and is a key component of common table salt. A household name that we use every day, chlorine is an S-tier element. Following chlorine is argon. Argon is the 18th element on the periodic table. Like other noble gases, argon is mostly inert and doesn't readily react with other elements. Argon is used in lighting applications such as fluorescent lights and incandescent light bulbs. Unimpressive but somewhat useful, argon is a B-tier element. Next is potassium. Potassium is the 19th element on the periodic table. Potassium reacts vigorously with water, producing hydrogen gas and potassium hydroxide. Potassium is incredibly important for muscle and nerve function and is also used in fertilizers to help strengthen a plant's ability to resist disease. Very important for everyday life, potassium is an A-tier element. Next on the list is calcium. Calcium is the 20th element on the periodic table. Calcium reacts with water to produce calcium hydroxide, a white powder that is used in sewage treatment, paper production, construction, and food processing. Calcium is essential for strong bones and teeth and is involved in muscle contraction and nerve transmission. Incredibly impressive in its capabilities, calcium is an S-tier element. Next up is scandium. Scandium is the 21st element on the periodic table. Scandium is relatively reactive and can form compounds with oxygen and other elements. It's often used in aerospace and sports equipment due to its lightweight and strong properties. Often overlooked but impressive nonetheless, scandium is a B-tier element. Following scandium is titanium. Titanium is the 22nd element on the periodic table. Titanium is known for its exceptional corrosion resistance due to its formation of a stable oxide layer. Titanium is as strong as steel but much less dense and has the highest strength to weight ratio of any metal. It's widely used in aerospace, medical implants, and sporting equipment. Incredibly strong and equally impressive, titanium is an A-tier element. Next on the list is vanadium. Vanadium is the 23rd element on the periodic table. Vanadium can exhibit multiple oxidation states, leading to its ability to form various compounds such as ammonium metavanadate, which is used in dyes and inks. It's also used in steel production and as a battery component for power grid applications. Pretty useful but not very eye-catching, vanadium is a B-tier element. After vanadium comes chromium. Chromium is the 24th element on the periodic table. Chromium is known for its resistance to corrosion thanks to its protective oxide layer. It's also used in stainless steel and for decorative plating on car parts, tools, and kitchen utensils. Not one that comes to mind very often, but still pretty useful, chromium is a B-tier element. Next up is manganese. Manganese is the 25th element on the periodic table. Manganese can undergo various oxidation states and can form compounds with oxygen and other elements. Manganese is a key element in steel production and is also important for plant health and photosynthesis. Important for industry and for our health, the manganese is a B-tier element. Next on the list is iron. Iron is the 26th element on the periodic table. Iron is reactive with oxygen and can form iron oxide, commonly known as rust, which we can find almost anywhere. Iron is a fundamental element for life and is a major component of hemoglobin, the molecule that carries oxygen in our blood. Iron is also the most abundant metal in the Earth's core, with the inner and outer cores consisting of about 80% iron. The most famous of all the metals, iron is an S-tier element. After iron comes cobalt. Cobalt is the 27th element on the periodic table. Cobalt can form stable compounds and complexes due to its reactivity with various ligands. Cobalt is also used in rechargeable batteries and in superalloys for jet engines. Pretty interesting in all aspects, cobalt is a B-tier element. Following the table leads us to nickel. Nickel is the 28th element on the periodic table. Nickel is generally unreactive in air, maintaining its lustrous appearance. Nickel is also used in a wide range of applications, most notably in currency in the form of coins, but it is also used in stainless steel due to its high resistance to corrosion. Very useful and very nice to look at, nickel is a B-tier element. Next we have copper. Copper is the 29th element on the periodic table. Copper can react with oxygen and moisture to form a distinctive green patina. It conducts electricity and heat, making it valuable for wiring and plumbing. Copper also helps your body in the production of red blood cells and keeps nerve cells and your immune system healthy. Incredibly important to both machines and to our bodies, copper is an A-tier element. Next on the list is zinc. Zinc is the 30th element on the periodic table. Zinc is relatively reactive with oxygen and moisture, forming a protective layer on its surface. Zinc is important for many biological processes as it helps your immune system and general metabolism functions. It is also used to galvanize steel in order to prevent corrosion. Good for the body and for the industry, zinc is an A-tier element. After zinc comes gallium. Gallium is the 31st element on the periodic table. Gallium has a very low melting point of roughly 30 degrees Celsius and can melt in your hand. It is mainly used in semiconductors and for medical applications as it identifies cells that are dividing the most quickly in your body. Very interesting to work with, gallium is a B-tier element. After that we get to germanium. Germanium is the 32nd element on the periodic table. Germanium was used in early history of electronics and played a significant role in the development of transistors. Germanium can form compounds with oxygen and halogens, but its reactivity is generally lower than some of the other non-metals. Not one that we see or use very often, germanium is a C-tier element. Next up is arsenic. Arsenic is the 33rd element on the periodic table. Arsenic has a notorious history as a poison, often being used to poison royalty during the Renaissance era. Arsenic can form compounds with various elements, particularly metals, and has a complex history of use, both for good and for bad. Very complex, but very fascinating, arsenic is an A-tier element. Following arsenic is selenium. Selenium is the 34th element on the periodic table. Selenium is an essential trace element for many organisms as it plays a key role in maintaining thyroid hormone metabolism. Selenium can form compounds with oxygen, namely selenium dioxide, which was used as a toner in photographic development. Something we truly can't live without, selenium is an A-tier element. Next on the list is bromine. Bromine is the 35th element on the periodic table. Bromine is a reddish-brown liquid at room temperature and is used in agricultural chemicals, insecticides, and chemical intermediates. Bromine is reactive and readily forms compounds with other elements, especially metals. Breathing in bromine gas can cause serious problems to mucous membranes and overall health. Violent but beautiful in its chaos, bromine is an S-tier element. After bromine comes krypton. Krypton is the 36th element on the periodic table. Krypton is used in some types of lighting, such as fluorescent lights and in lasers. Krypton is generally unreactive and doesn't readily form compounds under normal conditions, but can form krypton difluoride under certain conditions. Nothing to get too excited about, krypton is a C-tier element. Next we have rubidium. Rubidium is the 37th element on the periodic table. Rubidium is highly reactive and can ignite spontaneously in air. Since rubidium is so highly reactive with air and moisture, it is mainly used for research purposes. Incredibly reactive and quite dangerous, rubidium is a C-tier element. Next on the list is strontium. Strontium is the 38th element on the periodic table. Strontium compounds are used in fireworks to create red colors. Strontium also reacts vigorously with water and quickly tarnishes in air. Modern glow-in-the-dark paints and plastics contain strontium aluminate, a famous compound containing strontium and aluminum. Colorful in its presentation, strontium is a B-tier element. Following the table leads to yttrium. Yttrium is the 39th element on the periodic table. Yttrium is used in lasers, superconductors, and phosphors for displays and lighting. Yttrium reacts with water, decomposing it to release hydrogen gas, as well as reacting with mineral acids. Often swept under the rug, but still interesting nonetheless, yttrium is a B-tier element. After that comes zirconium. Zirconium is the 40th element on the periodic table. Zirconium is known for its resistance to corrosion and is used in nuclear reactors, dental implants, and jewelry. At normal temperatures, zirconium is not particularly reactive, but becomes quite reactive with a variety of nonmetals at elevated temperatures. Very interesting in its own right, zirconium is a B-tier element. Next up is niobium. Niobium is the 41st element on the periodic table. Niobium is often used in superalloys for aerospace applications due to its high melting point and strength. Niobium is relatively unreactive and forms a protective oxide layer on its surface, which helps prevent further corrosion. Intriguing but not interesting enough, niobium is a C-tier element. Following the list takes us to molybdenum. Molybdenum is the 42nd element on the periodic table. Molybdenum is essential for many enzymes in the body which help to break down drugs and toxic substances. Molybdenum is also used to increase the hardenability, toughness, and tensile strength of steel. Molybdenum is relatively unreactive at room temperature and doesn't readily oxidize in air. An essential part of everyday life, molybdenum is an A-tier element. Next comes technetium. Technetium is the 43rd element on the periodic table. Technetium was the first element to be artificially made, being produced in a 1937 experiment at the University of Palermo in Sicily. It has no stable isotopes and is often used in medical imaging. Technetium is highly radioactive, so its natural reactivity is not commonly observed. A historic example of the advancements of scientific research, technetium is a B-tier element. After that comes ruthenium. Ruthenium is the 44th element on the periodic table. Ruthenium is part of the platinum group metals and is used in electronics, catalysts, and jewelry. Ruthenium is generally unreactive and doesn't tarnish or corrode very easily. Generally underwhelming and not necessarily exciting, ruthenium is a C-tier element. Next up is rhodium. Rhodium is the 45th element on the periodic table. Rhodium is one of the rarest naturally occurring elements and is often used as a catalyst in car emissions control systems. Rhodium is unreactive and maintains its brilliant shine, making it useful for plating purposes. An interesting find but generally forgotten about, rhodium is a C-tier element. Following rhodium is palladium. Palladium is the 46th element on the periodic table. Palladium is another member of the platinum group metals and has applications in catalysis, electronics, and jewelry. Palladium is relatively unreactive and doesn't tarnish very easily, which contributes to its use in jewelry and catalysis. An exciting and fascinating metal, palladium is a B-tier element. After that comes silver. Silver is the 47th element on the periodic table. Silver has been used for thousands of years as currency, and its antimicrobial properties are exploited in medical settings. Silver doesn't react with oxygen or water at room temperature, which is one reason for its historical and practical use. A beautiful and incredibly important metal to society, silver is an A-tier element. Next up is cadmium. Cadmium is the 48th element on the periodic periodic table. Cadmium is a toxic element and its use in batteries has been limited due to environmental concerns. Cadmium is relatively reactive and can react with oxygen and acids, contributing to its toxicity. Incredibly important but certainly scary to work with, cadmium is a B tier element. Next on the list is indium. Indium is the 49th element on the periodic table. Indium is used in the production of LCD screens, touchscreens, and thin film solar cells. Indium is relatively unreactive in air and water at room temperature. Very useful but often forgotten about, indium is a C tier element. After that comes tin. Tin is the 50th element on the periodic table. Tin has been used since ancient times and its alloys like bronze have been very significant in human history. Tin doesn't readily corrode in air, but it can react with certain acids to form compounds. Tin is used for can coating, and tin-plated steel containers are widely used for food preservation. Historically important and still relevant to this day, tin is an A tier element. Following tin is antimony. Antimony is the 51st element on the periodic table. Antimony has a long history of medicinal use dating back all the way to ancient Egypt. Antimony is also used in making lead storage batteries, as lead-containing antimony is harder and more resistant to the action of acids than ordinary lead. Antimony is relatively unreactive with water and air at room temperature, but can react violently with certain halogens. Historically important but slightly irrelevant in modern times, antimony is a B tier element. Next up is tellurium. Tellurium is the 52nd element on the periodic table. Tellurium is a semiconductor and is often used in alloys to improve their machinability. Tellurium can form compounds with oxygens and halogens, but is generally less reactive compared to some other elements. Quite impressive in its capabilities, tellurium is a B tier element. Next on the list is iodine. Iodine is the 53rd element on the periodic table. Iodine is essential for thyroid function and is used for certain vital proteins. Iodine is also used in disinfectants, namely in iodopovidone, which is an antiseptic used for skin disinfection before and after surgery. Very important for everyday life, iodine is an A tier element. Following the table leads us to xenon. Xenon is the 54th element on the periodic table. Xenon is used in certain types of lighting, such as xenon arc lamps and in medical imaging. Xenon is a noble gas and is generally unreactive under normal conditions. Oftentimes forgotten about, xenon is a C tier element. After xenon comes cesium. Cesium is the 55th element on the periodic table. Cesium is used in atomic clocks, which are highly accurate timekeeping devices. Cesium is highly reactive with air and water, and even a small piece of cesium can cause a violent reaction with water. Quite rare but remarkably reactive, cesium is a B tier element. Next up is barium. Barium is the 56th element on the periodic table. Barium compounds are used in medical imaging as well as fireworks in order to produce a green color. Barium reacts with water and oxygen, forming barium oxide and hydroxide. Barium oxidizes in air and can react with almost all the non-metals, forming poisonous compounds. Very colorful but equally scary, barium is a B tier element. After that comes lanthanum. Lanthanum is the 57th element on the periodic table. Lanthanum is used in hybrid car batteries as well as a component in optical lenses. Lanthanum has the largest atomic radius of the lanthanides, which makes it the most reactive and can readily burn to form lanthanum oxide. Not the most impressive by any means, lanthanum is a C tier element. Next on the list is cerium. Cerium is the 58th element on the periodic table. Cerium is mainly used in catalytic converters to reduce vehicle emissions. Cerium is reactive with oxygen and water, and its compounds can exhibit both oxidation states. Often overlooked and underwhelming in its capabilities, cerium is a D tier element. Afterwards comes praseodymium. Praseodymium is the 59th element on the periodic table. Praseodymium is used in magnets for wind turbines and is also found in some electric vehicles. Praseodymium can react with oxygen and moisture, forming oxide and hydroxide compounds. Pretty interesting, but not too flattering. Praseodymium is a C tier element. Next comes neodymium. Neodymium is the 60th element on the periodic table. Neodymium magnets are incredibly strong and are used in many modern technologies, including headphones and electric motors. Neodymium metal reacts with all the halogens to form neodymium 3 halides. Quite magnetic but not quite fantastic, neodymium is a C tier element. Up next is promethium. Promethium is the 61st element on the periodic table. Promethium is one of the rarest naturally occurring elements on Earth and has no stable isotopes. It's primarily used in nuclear batteries and atomic clocks. Promethium is radioactive and not naturally abundant, so its reactivity is limited to laboratory studies. Very fascinating but somewhat limiting, promethium is a B tier element. Following promethium is samarium. Samarium is the 62nd element on the periodic table. Samarium is used in the production of powerful magnets and as a neutron absorber in nuclear reactors. The samarium 2+ ion is a powerful reducing agent that rapidly reacts with oxygen, water, or hydrogen ions. Not very exciting, but not the most boring either. Samarium is a C tier element. Next on the list is europium. Europium is the 63rd element on the periodic table. Europium is used in the production of red and blue phosphors for LED displays, as well as in the security features of banknotes. Europium is reactive with oxygen and can form compounds, especially in its divalent state. Flying under the radar but very useful indeed, europium is a B tier element. Afterwards comes gadolinium. Gadolinium is the 64th element on the periodic table. Gadolinium compounds are used as contrast agents in magnetic resonance imaging due to their ability to enhance image contrast. Gadolinium selenium reacts slowly with water and rapidly with diluted acids, except for hydrofluoric acid. Quite useful in the medical industry, but not much else. Gadolinium is a C tier element. Following that comes terbium. Terbium is the 65th element on the periodic table. Terbium is used in green phosphors for displays and fluorescent lamps. It is reasonably stable in air, but it is slowly oxidized and it reacts with cold water. Rarely talked about and nothing special, terbium is a D tier element. Next up is dysprosium. Dysprosium is the 66th element on the periodic table. Dysprosium is used in the production of powerful magnets for clean energy technologies and electric vehicles. Dysprosium slowly reacts with water and quickly dissolves in most diluted acids. Not the most impressive of the lanthanides, dysprosium is a D tier element. Following dysprosium is holmium. Holmium is the 67th element on the periodic table. Holmium is used in lasers for medical and dental applications, as well as in submagnets and electronic devices. Holmium is relatively stable in dry air at room temperature. However, it reacts with water and corrodes readily and also burns in air when heated. Generally appealing but somewhat lackluster, holmium is a C tier element. Afterwards comes erbium. Erbium is the 68th element on the periodic table. Erbium is used in fiber optic communication systems and as a pink colorant in glass and ceramics. Unlike other rare earth metals, erbium is stable when exposed to air as it slowly oxidizes when combined with oxygen. Quite interesting in its application, erbium is a C tier element. Next up is thulium. Thulium is the 69th element on the periodic table. Thulium is used in portable X-ray machines and is also being researched for potential use in cancer treatment. Thulium is quite electropositive and reacts slowly with cold water and quite quickly with hot water to form thulium hydroxide. Very rare and not the most interesting, thulium is a C tier element. Following thulium is ytterbium. Ytterbium is the 70th element on the periodic table. Ytterbium is used in lasers, fiber optic amplifiers, and certain medical applications. It can also react with water, decomposing it to release hydrogen gas. Very useful in a number of industries, ytterbium is a B tier element. Next on the list is lutetium. Lutetium is the 71st element on the periodic table. Lutetium is used in certain types of cancer treatment as well as in petroleum cracking catalysts. Lutetium is similar to calcium and magnesium in terms of its reactivity and is used for a variety of applications. Very useful for many different applications, lutetium is a B tier element. Afterwards comes hafnium. Hafnium is the 72nd element on the periodic table. Hafnium is used in nuclear reactors and is also being explored for its potential in semiconductor applications. Hafnium is relatively unreactive and forms a protective oxide layer which helps prevent further corrosion. Relatively mysterious but also intriguing, hafnium is a C tier element. Following hafnium is tantalum. Tantalum is the 73rd element on the periodic table. Tantalum is used in electronic components such as capacitors due to its ability to store and release electrical energy. In addition to capacitors, tantalum is also used as wave filters in mobile phones to improve sound quality. Tantalum is highly resistant to corrosion and can form a stable oxide layer. Very resourceful but oftentimes conflicting, tantalum is a B tier element. Next up is tungsten. Tungsten is the 74th element on the periodic table. Tungsten has the highest melting point of any element and is used in high temperature applications such as light bulb filaments. Tungsten is quite non-reactive as it does not react with water and is also immune to attack by most acids and bases. Quite powerful and surely useful, tungsten is an A tier element. Following the table leads us to rhenium. Rhenium is the 75th element on the periodic table. Rhenium is used in high temperature superalloys for jet engines and in catalysts for petrochemical processes. Rhenium is less reactive to air than manganese and is about as reactive as technetium, which is immediately above rhenium in the periodic table. Not much to rave about here, rhenium is a C tier element. Next we have osmium. Osmium is the 76th element on the periodic table. Osmium is one of the densest elements and is often used in specialized alloys such as those used in fountain pen nibs. Due to its density, osmium is unreactive with oxygen and moisture. Quite boring due to its limited applications, osmium is a D tier element. After osmium comes iridium. Iridium is the 77th element on the periodic table. Iridium is extremely corrosion resistant and is used in spark plugs as well as in certain types of scientific equipment. Since iridium has such a high density and melting point as well as being the most corrosion-resistant material known, it is generally unreactive. Quite impressive and useful in industry, iridium is a B tier element. Following the table leads to platinum. Platinum is the 78th element on the periodic table. Platinum is known for its use in jewelry as it is extremely durable and strong, making it ideal for jewelry that's worn on a daily basis. Platinum is also used in catalytic converters as it converts toxic pollutants like exhaust gas to less toxic pollutants by catalyzing redox reactions. Platinum is unreactive with most substances at room temperature and is highly corrosion resistant. Very important and quite remarkable, platinum is an A tier element. Next up is gold. Gold is the 79th element on the periodic table. Gold is highly valued for its beauty and its rarity. It's used in jewelry, electronics, and even space exploration. Gold is highly unreactive with oxygen and moisture, contributing to its long-lasting shine and historical use. Quite fascinating and equally impressive, gold is an A tier element. After gold comes mercury. Mercury is the 80th element on the periodic table. Mercury is the only metal that is liquid at room temperature. Mercury was historically used in thermometers but has begun getting phased out due to its potential toxicity. Mercury is generally unreactive with oxygen and doesn't readily form compounds, remaining in its liquid form at room temperature. Incredibly unique and impressive in its properties, mercury is an S-tier element. Next up is thallium. Thallium is the 81st element on the periodic table. Thallium was used as rat poison in the past due to its toxic properties, and now has applications in electronics and medical imaging. Thallium compounds can be reactive and toxic, and they have various oxidation states. Pretty standard and nothing special, thallium is a C-tier element. Afterwards comes lead. Lead is the 82nd element on the periodic table. Lead has been used for thousands of years, but its toxicity has led to its decreased use in many applications, including gasoline and paint. Lead is a moderately active metal as it reacts more rapidly with hot acids, but does not react readily with oxygen in the air. Historically important, albeit quite toxic and dangerous, lead is an A-tier element. Following the table leads to bismuth. Bismuth is the 83rd element on the periodic table. Bismuth is the most naturally diamagnetic element, meaning it's repelled by magnets. It is primarily used in medical treatments which target stomach and gastrointestinal problems. Bismuth is normally found in an oxidation state of +3 and reacts with halogens to form trihalides in this state. Quite interesting and fun to investigate, bismuth is a B-tier element. Next is polonium. Polonium is the 84th element on the periodic table. Polonium was discovered by Marie Curie, a famous Polish chemist, in 1898 while conducting research on radioactive elements. Polonium is highly radioactive and decays spontaneously, so its reactivity is limited to nuclear processes. Historically important but incredibly dangerous, polonium is a C-tier element. After polonium is astatine. Astatine is the 85th element on the periodic table. Astatine is extremely rare and highly radioactive, making it extremely challenging to study. The isotope of astatine with the longest half-life is astatine-210, which has a half-life of approximately 8.1 hours. The total amount of astatine in the Earth's crust at any particular time is less than 30 grams, and only a few micrograms have ever been artificially produced. So incredibly scarce that it's almost impossible to study, astatine is a D-tier element. Next up is radon. Radon is the 86th element on the periodic table. Radon is a colorless, odorless, and radioactive gas that can accumulate in homes and pose health risks. Radon is radioactive and inert under normal conditions, so its chemical reactivity is not typically observed. Quite harmful and dangerous due to its ease of exposure, radon is a D-tier element. Following radon is francium. Francium is the 87th element on the periodic table. Francium is incredibly rare and unstable, so it's difficult to study and has no practical applications. Francium is also highly radioactive, limiting its reactivity to laboratory studies. Practically impossible to work with, francium is a D-tier element. Next on the list is radium. Radium is the 88th element on the periodic table. Radium was once used in glow-in-the-dark paint, but its radioactivity led to health issues for workers who handled it. Radium is radioactive and decays into radon, so its reactivity is primarily observed within nuclear decay processes. Incredibly dangerous once again, radium is a D-tier element. Following radium is actinium. Actinium is the 89th element on the periodic table. Actinium glows faintly in the dark due to its radioactivity and is used in neutron sources for scientific research. Actinium reacts rapidly with oxygen and moisture in air, forming a white coating of actinium oxide that impedes further oxidation. Quite unique in its radioactive properties, actinium is a C-tier element. Next is thorium. Thorium is the 90th element on the periodic table. Thorium has potential as a fuel for nuclear reactors due to its abundance and its ability to generate less long-lived nuclear waste. Thorium is radioactive and can form compounds, but its reactivity is generally lower compared to some other elements. In need of further research and development, thorium is a C-tier element. Next comes protactinium. Protactinium is the 91st element on the periodic table. Protactinium is rare and highly radioactive, so it has limited practical applications due to its scarcity. Protactinium easily reacts with oxygen, water vapors, and acids, but not with alkalis. Quite scarce and quite boring, protactinium is a D-tier element. Afterwards comes uranium. Uranium is the 92nd element on the periodic table. Uranium is used as fuel in nuclear reactors and has played a significant role in the development of nuclear energy. Uranium is radioactive and can undergo fission, making it a key element in nuclear reactions. Incredibly important and highly valuable, uranium is an A-tier element. Next up is neptunium. Neptunium is the 93rd element on the periodic table. Neptunium was the first synthetic transuranic element to be synthesized and has applications in nuclear research. Neptunium is chemically reactive and is more similar to plutonium than to uranium, with oxidation states ranging from +3 to +7. Rarely used for anything outside of research, neptunium is a C-tier element. After neptunium is plutonium. Plutonium is the 94th element on the periodic table. Plutonium is used as fuel in nuclear reactors and has been also used in the production of nuclear weapons. Plutonium is highly reactive in air and strongly reducing in solution, forming multiple compounds and complexes in the environment. Historically important, but for the wrong reasons, plutonium is a C-tier element. Next up is americium. Americium is the 95th element on the periodic table. Americium is used in smoke detectors due to its ability to ionize air and create an electric current. Americium metal readily reacts with oxygen and dissolves in aqueous acids, with its most stable oxidation state being +3. Useful for detection but not for much else, americium is a C-tier element. Following the list leads to curium. Curium is the 96th element on the periodic table. When absorbed into the body, curium accumulates in the bones and its radiation destroys red blood cell formation. Curium is very reactive, tarnishing in the presence of oxygen, steam, acids, and even dry nitrogen. Quite toxic for the body and equally dangerous, curium is a D-tier element. Next up is berkelium. Berkelium is the 97th element on the periodic table. Berkelium is highly radioactive and has no significant practical applications due to its scarcity. Berkelium is extremely dangerous because it is a very powerful source of radiation, but one is highly unlikely to ever be exposed to it due to its scarcity. Incredibly rare and not very useful, berkelium is an F-tier element. After berkelium is californium. Californium is the 98th element on the periodic table. Californium is used in neutron sources and has been explored for potential applications in cancer treatment. Californium slowly tarnishes in air at room temperature with small pieces of the metal oxidizing. Intriguing in its name but not in its chemical properties, californium is a D-tier element. Next comes einsteinium. Einsteinium is the 99th element on the periodic table. Einsteinium is named after Albert Einstein and is produced in nuclear reactions, but has limited uses due to its radioactivity. Einsteinium is highly reactive and therefore strong reducing agents are required to obtain the pure metal from its compounds. A nod to the great scientist, but not much else, einsteinium is a D-tier element. Fermium is the 100th element on the periodic table. Fermium was named after Enrico Fermi and is produced in particle accelerators, but has no practical applications. Fermium is found in very small quantities, so scientists predict that its reactivity might resemble that of erbium. Too rare to really make a name for itself, fermium is an F-tier element. Up next is mendelevium. Mendelevium is the 101st element on the periodic table. Mendelevium is named after Dmitry Mendeleev, the creator of the periodic table. Mendelevium is a radioactive metal of which only a few atoms have ever been created and has no known biological role. Named after the man who started it all, but not practical in any way, mendelevium is a D-tier element. Afterwards comes nobelium. Nobelium is the 102nd element on the periodic table. Nobelium is named after Alfred Nobel, the inventor of dynamite. It's a synthetic element and is primarily used for scientific research. Nobelium is highly radioactive and highly unstable, with limited observable chemical reactivity. Used primarily for research and nothing else, nobelium is a D-tier element. Next up is lawrencium. Lawrencium is the 103rd element on the periodic table. Lawrencium is named after Ernest O. Lawrence, a pioneer in nuclear physics. Lawrencium doesn't occur naturally, it has not yet been found in the Earth's crust, and is so unstable that any amount formed would decompose to other elements very quickly. Practically non-existent and with little to no use, lawrencium is an F-tier element. After lawrencium is rutherfordium. Rutherfordium is the 104th element on the periodic table. Rutherfordium is named after physicist Ernest Rutherford. It has 12 recognized isotopes with known half-lives, the most stable being rutherfordium-263, which has a half-life of 10 minutes. With very little use for potential, rutherfordium is a D-tier element. Next on the list is dubnium. Dubnium is the 105th element on the periodic table. Dubnium is named after Dubna, Russia, where it was discovered. Dubnium is a highly radioactive element with only one single stable isotope, dubnium-268, which has a half-life measuring about only 32 hours. Not much to see here apart from an interesting name, dubnium is a D-tier element. Following the table leads to seaborgium. Seaborgium is the 106th element on the periodic table. Seaborgium is named after Glenn T. Seaborg, a nuclear chemist, and was first produced at the Lawrence Berkeley Laboratory in Berkeley, California. It was made by bombarding atoms of californium-249 with ions of oxygen-18 using a machine called the Super Heavy Ion Linear Accelerator. Due to its existence only appearing in the lab, seaborgium is a D-tier element. Next is bohrium. Bohrium is the 107th element on the periodic table. Bohrium is named after Niels Bohr, a world-renowned physicist who made contributions to atomic theory. Bohrium is incredibly rare, with only a few atoms ever being produced, and its most stable isotope, bohrium-262, has a half-life of 17 seconds. Unstable and unimpressive, bohrium is a D-tier element. Afterwards comes hassium. Hassium is the 108th element on the periodic table. It is synthetic and highly radioactive with no practical applications. Hassium is a super heavy element and has only ever been produced in a laboratory in very small quantities. Incredibly scarce and impractical in almost every way, hassium is a D-tier element. Next up is meitnerium. Meitnerium is the 109th element on the periodic table. Meitnerium is named after physicist Lise Meitner. It is a synthetic element that is made by bombarding bismuth with iron atoms. According to the Royal Society of Chemistry, fewer than 10 atoms of meitnerium have ever been made and will likely never be isolated in observable quantities. Incredibly elusive and not very impressive, meitnerium is an F-tier element. Next on the list is Darmstadtium. Darmstadtium is the 110th element on the periodic table. Darmstadtium is named after the city of Darmstadt, Germany, where it was discovered. The element was made by bombarding lead-208 atoms with nickel-62 atoms in a heavy ion accelerator and resulted in 4 atoms of Darmstadtium being produced in the first experiment. Practically non-existent and likely to never be used in application, Darmstadtium is an F-tier element. Afterwards comes Roentgenium. Roentgenium is the 111th element on the periodic table. Roentgenium is named after Wilhelm Conrad Röntgen, the discoverer of X-rays. Roentgenium has 7 isotopes whose half-lives are known, with the most stable isotope being Roentgenium-281 with a half-life of about 26 seconds. Incredibly limited in terms of its potential uses, Roentgenium is a D-tier element. Next on the list is Copernicium. Copernicium is the 112th element on the periodic table. Copernicium is named after Nicholas Copernicus, a famous Renaissance astronomer. Copernicium is a synthetic radioactive metal produced by bombarding lead-208 with zinc-70 in a heavy ion accelerator. Incredibly unlikely to ever be used outside the lab, Copernicium is a D-tier element. Following the table is nihonium. Nihonium is the 113th element on the periodic table. Nihonium is named after the Japanese word for Japan, where it was discovered. Nihonium is extremely radioactive, with its most stable known isotope, nihonium-286, having a half-life of about 10 seconds. With almost no use outside of research, nihonium is a D-tier element. Next is flerovium. Flerovium is the 114th element on the periodic table. Flerovium is named after physicist Georgy Flyorov. The longest-lived isotope is flerovium-289 with a half-life of 2.6 seconds. Nuclear theory suggests that isotope 298 with 184 neutrons should be more stable, but is yet to be made. Incredibly unstable and uneventful, flerovium is a D-tier element. Afterwards comes moscovium. Moscovium is the 115th element on the periodic table. Moscovium is named after Moscow, Russia, where it was discovered. The first atoms of moscovium were produced by bombarding americium-243 with calcium-48 ions to form 4 atoms of moscovium. Likely to never be seen outside of a lab, moscovium is a D-tier element. Next on the list is livermorium. Livermorium is the 116th element on the periodic table. Livermorium is named after Lawrence Livermore National Laboratory in the United States. Livermorium was first produced on July 19, 2000, with a single atom of livermorium-293 being observed from bombarding a curium-248 target with calcium-48 ions. Incredibly short-lived and almost unheard of, livermorium is an F-tier element. Following livermorium is tennessine. Tennessine is the 117th element on the periodic table. Tennessine is named after the state of Tennessee, where Oak Ridge National Laboratory is located. Tennessine has 2 isotopes with known half-lives and 2 with unknown half-lives. The most stable isotope is tennessine-294 with a half-life of about 80 milliseconds. With only a few atoms ever being produced and with so little known about it, tennessine is a D-tier element. And last but not least is oganesson. Oganesson is the 118th element on the periodic table. Oganesson is named after physicist Yuri Oganessian. Oganesson has 1 known isotope, oganesson-294, with a half-life of about 0.89 milliseconds. Through alpha decay, it turns into livermorium-290. Simply because it is the last element on the periodic table, oganesson is a C-tier element. And there you have it, all 118 elements range from hydrogen to oganesson. Each element is amazing, unique, and beautiful in its own right, but this tier list shows that some are simply better than others. Whether you're driving your car to work or baking a cake, chemistry is all around us, and it's all thanks to these elements found on this incredibly impressive table. Let me know what you think down below, and until next time, keep on experimenting.